Hello everyone. In today's Computer Network Lab class, we will discuss a program under part A. So we will be discussing program 2, which is to simulate the transmission of ping messages over a network topology consisting of 6 nodes and find the number of packets dropped due to congestion. That means we have to have two types of traffic. One is ping messages, the other one is the regular congestion. Okay, and we also have to create 6 nodes. So if you before this, I prefer you should watch program 1. You should know that thoroughly. Then if you come to this, it would be more easier for you. Now let us see how to implement the logic in NS2. First, we are actually creating the simulator here. What are we doing? Set NS new simulator. So what are we doing here? An object called NS, okay, an object called NS will be actually created within the class called simulator. An object called NS will be created within the class called simulator with the help of this new operator. Okay, we have created an object NS of class simulator. So then we are actually defining two colors, use colors to differentiate the traffic, because here we have two types of traffic, right? So color 1 is blue. We will actually later point of time in the code we will use this blue for ping messages, ping traffic. Okay, it's not ping, it's ping, ping. Okay, so what is this ping? I'll let you know. And color 2 is actually for red color we are using, that is the normal congestion traffic that we are generating. So now what is this ping message actually? If you want to know in detail what is this ping message, ping command, right? Ping command is actually used to determine the connectivity of the TCP/IP network. That means whether that node belongs to the network or not. So that is the ping message. That means you are pinging that message, pinging that server or system to know whether it is still existing in that network. So that is the ping message. Okay, so yeah, now what are we doing next? We are actually open the trace and nam trace files. These two things we know, right? These are the two important files. So trace file is kind of a log file, we keep logging all the things, and nam stands for network animation. So when we execute that file, only then we'll see the GUI part of the simulation, right? Animated network animation file. Okay, so in these 4 lines we are actually set and trace open program 2.tr, and we are opening it in the write mode. And next is trace all and trace. So what am I doing in this trace and in nnam file? These 2 lines, all data that I get from this one, right? From these things, these are trace and nam files. These are all pushed to the simulation. Okay, these are all pushed to your simulation. So that's what we are actually doing in these 2 lines, and in these 2 lines I'm actually creating those 2 files in write mode. Yeah, I have the finished procedure here. I'll come back to it whenever I am calling it in the code. I'll not go into it right now. So next, what am I doing? Creating 6 nodes. So any procedure, you have to actually procedure name and then the arguments and also the beginning of it. So all these 3 things should come in a single line. Okay, you can observe that in this finish procedure also. Finish and then argument list, it's empty, and beginning. Generally in other languages we start this one in the next line, right? But in network simulation, whenever you are writing .tcl, so you have to put all these 3 in the same line. You have to remember this. If you just put this in next line also, you'll get a error message. Okay, so I need to create 6 nodes. That's what my program talks about, right? Create 6 nodes. So I'm just creating that in a for loop. It is just a simple for loop. Inside that, set and ns node. So this is the syntax for creating the node. I'm running it for 6 times. So I have created 6 nodes. So I have to connect the nodes now, right? Again I am going getting inside a for loop for connecting it, and again I'm using the duplex link. What is a duplex? It is actually a full duplex. That means you can send as well as receive the data at a time. So yeah, I have created the duplex link, and this is the so you know this one, right? Whenever you are creating the link, you have 6 parameters. What are they? First one is 7 parameters. Simulator class, and then type of the link. What next? Sender node. What is the sender node? I'm incrementing it each time. And then destination node. Okay, and then bandwidth. What is the bandwidth here? And what is the simulation time required, and then the queue type. So queue type, again here we are using drop tail. So once the queue is filled, the remaining packets will be dropped. So these are the 7 parameters that we need to connect the nodes whenever creating the link. So yes, all the links are created because I am doing it in a for loop. So define the RECV is a function, okay, receive function for the class agent ping. What are we doing here? See, what is this agent now? We have been using this word, right, so many times. What is this agent then? These agents, right, these agents are actually used to separate protocol states from nodes. That means I can actually just create a separate protocol suite for each particular node. Okay, that's what these agents are doing. Agents are used to separate protocol states from nodes. They are always associated with node. So each agent, whatever you create here, they should be associated with the node, so that that node will get the characteristics of whatever agent you have defined here. Okay, and anyway, all the agents will have a unique name, so that it can be identified with that unique name. So here I am creating the ping agent. Okay, whatever the ping messages that I need to create, right? So this is agent ping. Okay, and then inst proc, a procedure name, receive, and then from RTT self inst variable node underscore. So put, what am I doing here? So this is the agent. Okay, so what it does, it actually node, this we will see in the output. This puts is nothing but your printf only. Okay, this puts is actually nothing but the printf only. And yeah, so received ping from the node, this one particular node from round trip time. So I'll from this particular function I also get the RTT time, round trip time. Okay, for a message to go to the destination and to come back, right? That is the RTT. So here what am I doing? I'm creating an agent for ping message, right? And I'm also printing the statement that this particular node actually received the ping answer from this particular node, and with the round trip time I'll fetch the round trip time as well. Clear? So I have actually used RECV function for the class agent ping. That is clear, right? So this I am using that particular RECV function to create the ping messages. So now, okay, create 2 ping agents and attach them to N0 and N5. So ping messages will be from these 2 nodes, N0 and then N5. Let us see how it works. Set P0, okay, new agent ping. Okay, I am actually attaching that agent to P0. Set class 1. See, we defined that, right? One is nothing but blue color. Right, class 1 is actually blue color, color 2 is actually red. So here for ping I am using blue color. Clear? For ping I am using blue color, and I am attaching the agent to node 0. I am attaching that agent to node 0. And here again for P1 new agent ping, I am creating one more object of this ping agent class. Here also I created one object of this ping agent class, and here one more. So I am associating that to, again I have selected blue color, class 1. Okay, here you should observe it's underscore space 1. You have to follow the same syntax, same spacing. And now I am attaching that ping to node 5. So I am generating the ping messages from node 0 and then node 5 only. And then what am I doing? I am connecting these 2 instances, P0 and then P1. Okay, I have connected those 2 instances. Next, what am I doing? Okay, ping things are done. Now I need to generate the normal other traffic and then queue size and everything, right? So here I have set queue size and monitor the queue. So what am I doing? Queue size is set to 2 to observe the drop in the packet. So I am setting the queue size as 2. 2 to 3, queue size is 2. Okay. So again here also queues pos 0.5. Okay. So next, create the congestion. What is this create congestion? What am I doing here? So I need to generate the same CBR traffic here. Do you remember in program 1 also we discussed about this traffic? That is nothing but the constant bitrate traffic. CBR is nothing but constant bitrate traffic. So CBR traffic between 2 and 4. So for that you already know that, right? Again I need to create the agent here, TCP of type TCP, right? And then I am setting it to class underscore space 2. That means it is red color. CBR traffic will be displayed in red color, and I am attaching that agent to the node 2 as well as node 4. Okay, I am creating 2 instances for TCP 0 and then sync 0, and I am attaching them to node 2 and then node 4. At the end I am connecting both the objects, both the instances here. So yeah, I have created this CBR traffic, that is constant bitrate traffic. Now I need to apply that, right? Apply CBR traffic over TCP. How am I applying it? I need to define few things, right? What is the rate of this constant bitrate traffic? It is 1 MB and packet size is 500, and we are attaching the agent TCP 0 here. Okay, CBR 0, new application traffic CBR. This is the syntax that you have to remember. And now yes, I have everything ready, but I need them in a sequence, right? So I need to schedule the events. What and all I need to? First, P0 send. What is my P0? See here. What is my P0? P0, ping messages, right? P0 is here. This one, $symbol P0. So first I'll send that one. So that means I have created the ping messages, and then P1 send. So I have created one more, I have sent one more ping messages, right? From which node? P1 is for, P0 is for P0. P0 is for node 0 and P1 is for node 5. So I have started, first I have started with node 0 at simulation time 0.2. So I have sent this one. At simulation time 0.4 I have started ping message from node 5, node 0, node 5. And next, CBR 0 start. What is this CBR 0? Just now we defined, right? CBR messages, CBR traffic, constant bitrate traffic. So here I have this CBR 0, right? So CBR 0 is this. That means I am actually generating the traffic, the regular traffic from 2 to 4. Node number 2 to 4. That's what it is, right? So I start that here, and then again I start the ping messages, and then I am stopping the normal congestion messages. Okay, but that is CBR. Again I send the ping message. Yes, finally I call the finish procedure. So what is my finish procedure is having? The one we didn't touch in the beginning, right? Yes, finish procedure is here, procedure finish, and you should have the procedure name, argument list, and then the beginning flower base in the same line here. Yes, and I have defined global NS entries and NAM files. I have created 2, and then we are actually dumping all the trace file data and close the file. So I just flush the trace, close entries file, close NAM file, and now I need to execute the NAM animation file. Okay, so execute NAM program.to.nam, and I have executed that. Now I'll have the trace file ready. Find the number of ping packets dropped, right? I need to just find out the number of only the ping packets. My trace file will have both congestion message traffic as well as ping drops, right? I need to identify only ping. How do I do that? Anyway, this using the grep command that I used to count the D's here from program.to.trace file, right? So I have identified this, plus it should be D, plus the message type should be ping. In the trace file I'll just show you, it will be 5. The fifth during execution, observe, I'll just tell. So the 5th position is ping. Okay, so I'll just take the lines only with D as well as ping. I'll show that during execution. So where the lines where I have D as well as the in the fifth position, if I have a ping, that means it is a ping message. So I'll count only those things, and then I'll just display that and exit. So here I am displaying it, right? The number of ping packets dropped are this one. So after that, what do I have? Yes, that's it. Run the simulation. Simulation will start. So yeah, this is about the code. Now let us see the execution part of it. How can we execute and how to analyze the output. I have logged into Ubuntu. Make sure you have NS2 installed on it. Let me open the terminal now. Click on the terminal. Yeah. Now I am using VI editor to write the code here. So what I need to do, I need to type VI file name, that is in my program 2.tcl. Okay. So next, to insert, you have to click I, type I, so that you will get into insert mode. Type in your code here. I am just pasting it. So after typing the code, you have to click escape to save and exit. Okay, to save and quit, you have to type escape and then :WQ. Just press enter. Hit enter. So you will be back to this terminal. Now you have to execute ns program 2.tcl. You have to execute the network simulator program. So after executing, yes, we got the NAM file as well as the output. So now let us see what exactly is the output that we got. Okay, so let me just maximize it. So we got both, yeah. So node 0 received ping answer from 5 at round trip time 151.2 milliseconds. So these are the things that we are printing from the code, right? When exactly we are actually sending the ping. So again, node 0 received ping answer from 5 at round trip time 301.4 milliseconds. Next one. So node 5 actually received the ping answer from 0 at round trip time 155.4 milliseconds. Okay, so these are the 3 messages that I am printing, and number of ping packets dropped are 3. 3 ping packets are actually getting dropped. Let me see here. Let me run the simulation. See here, the simulation time has started. So this blue traffic is nothing but the ping traffic. Okay, what are ping messages, and this red is the normal CBR, the congestion that we are creating here. Okay, so even both packets are getting dropped. You can observe both red packet as well as the ping messages. Both packets are getting dropped. So we need to only count the ping messages that are getting dropped, the blue ones. Okay, so blue ones, and blue is the ping and red is the congestion. Okay, so let us see how do we calculate that from the trace file. Let me, yeah, so simulation succeeded. Let me open the trace file here. So yeah, we know the number of packets dropped are 3. Let me open the trace file, which is saved as program2.tr. So here, see here, the 5th position, right, whatever I have, that will be ping. See, for example, I have 5 drops. We know that, right? D is nothing but the drop packet got dropped. So in that one, we need to just check how many are ping packets. You can see that, right? 1, 2, 3, 4, 5th one. 5th column, you can see it is ping. So TCP is also there, ping is also there. You have to only count the one with ping, because we are only calculating the ping packets dropped. So yeah, this one is ping and this is TCP, so we are not going to count this one. The count is still 1 only. So the next packet dropped is TCP. Again, I'm not going to count this. So this is a ping. So my count becomes 2, and yeah, this is also ping. That means hence I got the number of ping packets dropped are 3. So you got it, right? How to check it? Check your output from the trace file. So yeah, this is all about the execution. Thank you.